Hi guys, thank you for joining us tonight. I'm glad you're here. My name is Luba. I'm event specialist at Intellias. So today we're going to talk about the price of JavaScript flexibility and prototype pollution. While others are joining, let me tell you a bit more about our company, about Intellias. So interesting projects, international clients, global representation, 8 development centers, and a lot of open positions. So that's what Intellias is about. With over 3,200 experienced engineers, we basically do a lot of great stuff, and we develop things that are used by over 2 billion people in the world. So I will send you the link to our website. If you have time, come and check it out. Maybe you'll find something interesting for you. And now some just technical issues. I want to let you know that probably we won't have enough time for a Q&A session tonight. So leave your questions in the chat and we will answer them in a follow-up email tomorrow or on Monday, also with the recording of this event and the presentation from our speaker. Basically, that's it on my side. I'm glad to introduce our speaker. It's Philip, a penetration tester and security engineer at Intellias. Glad you're here, Philip. Good luck, and the floor is yours.
Hi, everyone. Welcome to our session again. Let me share my screen, and I'm sorry, I need to turn off my camera because it could cause some connectivity issues. Nowadays, it's common thing. But let us begin. Today, we will discuss a thing that is called prototype pollution. We will start with small introduction in the beginning and then proceed to technical things from JavaScript basics to prototype pollution. Let me also introduce myself again. I'm Philip, a penetration tester with 4 years of experience, especially with focus in web and mobile applications. I'm also a holder of cybersecurity certifications such as BSCP, Hack the Box Dente, and other e-learn security certifications. I'd like to mention when discussing prototypes, it is important to note that this speech is about JavaScript language and not JS framework and its models and libraries. Also, the purpose of the topic is to describe the problem from the security perspective. So if there are some inaccurate definitions about JavaScript details, please let me know in the chat. So let's move to this one specific slide and begin with a short overview. Node.js is a runtime that allows developers to build server-side application using JavaScript. It is open source, it is cross-platform. Node.js uses V8 JavaScript engine. The same engine is also used in Google Chrome to execute JavaScript code, as well as in many other applications. In 2021 and 2022, Node.js continues to be a popular choice among developers for building server-side applications. According to the Stack Overflow Developer Survey 2021, Node.js is the 4th most popular technology among developers, behind only HTML and CSS, JavaScript, and SQL. The same survey also found that Node.js is the 2nd most loved technology among developers, behind only Rust. Additionally, Node.js user survey of 2022 revealed that Node.js is used by more than 50 developers in the United States and Europe. And it is the most popular runtime for microservices. But there is a problem. According to CVE Meter organization, the prototype pollution vulnerability was discovered more than 200 times in total from 2018 to 2022. It affected different and quite popular JavaScript libraries. But what is it? Prototype pollution is a type of vulnerability that occurs when an attacker could modify an object's prototype, either by directly modifying it or by injecting properties or methods into it. This injected value is processed by JavaScript function that merges user-provided properties into an existing object without sanitizing user input. In general cases, the vulnerability occurs when an attacker can inject a malicious property using proto property. This allows the attacker to corrupt the object's prototype with properties that contain harmful values, which the application can then use in a dangerous manner. This vulnerability appears in both front-end and back-end JavaScript libraries. For example, Lodash potentially affecting many front-end projects due to the popularity of this library, as well as Node.js backend libraries, NodeExtend or DeepExtend, or any other custom implementations that deal with JavaScript object cloning. For the successful exploitation of prototype pollution, the following factors must be present. A vulnerable property that is passed to the thing without being sanitized. A vulnerable thing that such as JavaScript function or DOM element where a provided input property is processed, and a source of prototype pollution, such as URL parameters, JSON-based input, or web messages. So, what can it lead to, and what are the consequences? It depends on whether the prototype pollution is client-side. In this case, it leads to cross-site scripting, client-side denial of service, HTML injection, or other types of injections that could affect only front-end application. But in case server-side, which is actually harder to find, but it results in remote code execution, privilege escalation issues, and other type of injections like SQL injections, multiple or cross-site scripting, etc. It very depends on the context of the thing. But I do really love this word, but it's like an addiction. Before uncovering more technical details of this kind of web application vulnerability, we need to deep dive into JavaScript basics and understand what's under the hood. Let's also recap what documentation say about JavaScript basics that are important for us, so everyone understands the difficulty, impact, and exploitation of a prototype pollution vulnerability. The first and the most important rule: in JavaScript, almost everything is an object. Booleans, numbers, strings could be objects if they were defined with the new keyword. Then we have dates, math, regular expressions, arrays, functions, and objects that are always objects in JavaScript. So all JavaScript values except primitives are objects. Primitives or primitive values. Primitive values are values that have no properties or methods. For example, a number 314 is a primitive value. JavaScript defines 7 types of primitive data types: string, number, boolean, null, undefined, symbol, begin. Primitive values are immutable. They are hard-coded and cannot be changed. So as in the table, we have several examples. String hacker is always hacker and is immutable. The same applies to number 10, Boolean values true and false, etc. A JavaScript object is a collection of named values. Named values in JavaScript objects are called properties. In other words, property is also a value associated with a JavaScript object. The object is a collection of unordered properties. It's common practice to declare objects with const keyword or let keyword. For example, here we create an object neighbor with and define the following properties: first name, last name, and age. Since we created an object, we are interested in accessing its properties for further goals. In different contexts, for example, the application could use some properties for processing user-provided input or values that were already created and do something on this. We can use bracket or dot-like notation to access object's property, as in the following examples. In JavaScript, we also have methods. A JavaScript method is a property containing a function definition. Methods are actions that can be performed on objects. It is also would be right to say methods are functions stored as object properties. An example of method is shown in the table, where we have a method that is called full name, which concatenates the first and last name, actually. When a developer wants to create a lot of similar objects with similar properties and methods, there arise constructors. Constructors actually functions with some properties and methods. In the example below, we have a function person, which is an object constructor function. It accepts some arguments and defines some future properties for all objects that will be created with using this constructor. Objects of the same type could be created by calling the constructor function with the new keyword. In our specific example, we create an object from constructor object neighbor from constructor person, defining neighbor equals new person and provide some first name, last name, like Mikola Kosak, and his name, his age, 50. There is a small limitation implemented in JavaScript. You cannot just assign your specific property in dynamic runtime or property or method to an object constructor directly. You cannot do this. As you can see, when you define some constructor and then we use person.worker and assign some value true, this will not work. But we can create an object inherited from this constructor and assign the property directly to the object. This will work, and this is how it was intended. The type of creating objects from a constructor is a prototype inheritance. Date objects inherit from date prototype. Array objects inherit from array prototype. And our created constructor helps person objects to inherit from it. The most important in this moment that all of them, date, array, person, are inherited from object prototype, because object in JavaScript is on the top of inheritance chain. Above object is just null. Sometimes you want to add new properties or methods to all existing objects of a given type or to object constructor. In previous examples, it was impossible using direct assigning. But here we have that JavaScript. Here we have a prototype property which allows you to add new properties to object constructors. In the following example, as you can see, after the constructor declaration, we refer to person constructor using person.prototype and assign new property nationality to the constructor. At the same time, all existing objects inherited from this specific person constructor prototype, they will be updated so they have the newly assigned property, as well as all the objects that will be created later from this specific prototype. The JavaScript prototype property also allows you to add new methods to object constructors. In an example, we assign a method name to person prototype, which concatenates first and last name. Then when we create an object citizen from our person constructor and try to access its property and method, we will have a corresponding output. One more important moment. In JavaScript also exists a deprecated proto property. It's deprecated because of security reasons, and Firefox is trying to prevent, as I know, they are trying to prevent using it, and maybe they will stop you use this proto property in their future updates. This property serves as both as a getter and setter for objects prototype and could be used to read prototype and its properties, and even reassign these prototypes and its properties if necessary. Let's assume we create an object user with the property username and user ID. The username is, in our case, is a string, so it was inherited from string prototype. And in this chain, string was inherited from object prototype. The very similar example to user ID. It's a number that was inherited from number prototype, and number was inherited from object prototype in this chain. So when we use this proto property, we can refer to objects prototype, as it was mentioned before. We can chain it like double in order to access a prototype of our prototype. So like it was mentioned on the previous slide, in the chain, when we use double proto on username, we already refer to object prototype. So if we assign some property or method using double proto, we will assign this specific property or method to all the existing objects because they were inherited from object prototype. Sometimes nowadays we can meet some applications with proto prohibited already. So it is hard to eject. We have in JavaScript a pretty similar, but not the same way to refer to constructor of an object. Using syntax of constructor prototype and assign its the same, we can use dot and brackets notation to refer to it. Let's move to practical examples, shall we? Let's assume there is a target application that has the functionality of user account creation. Users can modify their accounts. Also, the application has some separate admin-only logic, and successful exploitation of the prototype pollution vulnerability will lead to privilege escalation for all users in the applications. Let's inspect how. Assume a client created a user account with username Mykola Porosuk. Then a developer creates an account. Actually, the way it was created doesn't matter. They could create it like during runtime of the application dynamically, doesn't matter. But the following code part is where the application checks the admin user has the property is admin with the value true assigned. And if not, assigns it to that specific user. Then the application proceeds with its admin logic, doesn't matter. It looks almost legit, but as I mentioned before, the application also has some logic that allows to modify user accounts. And the application, this specific application, does not perform proper sanitization on user-provided input. So the client could send the following JSON-based request, like patch users example, in order to update their biography and also to inject this proto property and assign is admin true. Since the proto property is injected equally, not injected not to specific property, but the object user, it will refer to object prototype, and it will try to assign is admin true globally to all objects. What happens next? The application performs some passing on the user provided input, and then it has a custom function deep copy which performs copying key value pairs from the object to the destination object. It does this action recursively, so no property will be left not copied. And it's where the problem begins. It happens actually when this function is called on a global object, happens this one thing. The destination is a global object or any other object or constructor that could be a prototype used by the application in context of user accounts or different scenarios. The function results in a privilege escalation through the successful exploitation of prototype pollution vulnerability. Since that moment, every user and every object actually in the application will have the property is admin true. Nice. Let's also cover other cases. For example, the exploitation of a prototype pollution that leads to obtaining a remote code execution on a server. The application has the following code, as you can see on the screen, which leads to some problems. So let's inspect. The application's purpose was to accept some messages from users and forward them to admin users. Simultaneously, it performed show command execution to trigger the log script. As we can see, the application definitely uses a Lodash vulnerable the application definitely imported Lodash library and prepared exec object. It uses here a merge function from user provided input into some object, in our case, message. Then the application performs some show execution, command execution. If we inspect this command execution function, exec method actually accepts many options, different options. These options are usually set implicitly, but in case of prototype pollution, we can redefine some of them explicitly. So they will have the only options we need, only values that we need to execute, to achieve remote code execution. The exploitation leading to remote code execution will look in this case like this. We send a request containing a message, and we inject something with it. Specifically, we inject proto property, and we define that following properties as shell argv0 and not options will have these specific values. As you can see, I also put some command into argv0 part in order to make some proof of concept. Then, when the application was successfully polluted, a file in temporary directory was created, and when we try to read it, it has that specific proof of concept content. Is it that only remote code execution scenario? No. As you can see, there are already a lot of different scenarios leading to remote code execution that already have been discovered. You can find them at resources such as Factrix or others, for example. But you may ask how to find prototype pollution on your own. Here we have several options. For front-end applications that will be inspected, the DOM invader created by Postfigure is doing well. They actually have a well-written documentation on it and hands-on labs. In case of both front-end and back-end applications, especially if you have a white box approach, you must check all the libraries for being outdated and vulnerable to prototype pollution. In this case, you can keep your libraries up to date and use only safe to this specific vulnerability. So you will not have any prototype pollution in this case, if you update it. And then as a last option, you can look for some custom functions, especially if they are performing any scenarios of object copy, especially recursively. And you can inspect if they use any kind of sanitization or checks for allowed options. So one of the most important part of today's discussion, we talked about already the vulnerability itself. Let's talk about its remediation. You can use freeze properties with object freeze to mitigate the prototype pollution vulnerability impact. You can perform validation on the JSON inputs in accordance with the application schema. You can avoid using recursive merge functions, especially custom ones, in an unsafe manner. Use objects without prototype properties, such as object create now, to avoid affecting the prototype chain. Use map instead of object, and regularly update new patches for libraries. Is that it? No, I also have some additional useful information for security guys. Where to get the hands-on experience, since the topic could be not that clear, I assume. At this moment, I found several resources that are useful in this topic. We have now Portswigger Academy. They have client-side prototype pollution labs, a good theory about client-side prototype pollution, everything that you need to know. At Hack the Box, you might find, you can probably find a pollution live machine right now. One of its steps has prototype pollution vulnerability and breaking red web challenge. At Pentester Labs, there is an only lab, JavaScript prototype pollution actually. And if you want to try more, you can Google for Guacamole Lite application and publicly available report on prototype pollution in this application. It's not that big and easy to follow. So you can just run this application in Docker and try all the possible scenarios that could happen in that application. Okay. Thanks for your attention a lot. Please also find after the presentation last slide useful references for you that contain different examples of custom unsafe functions, documentation, some tips, and additional other relevant things. For those who wants to screen, I show it here. Thank you.
Thank you, Philip, for a great presentation. As I mentioned before, we will send you the follow-up. If you have any questions, please leave them in the chat. And also, yeah, I will send you the feedback link. It will be very important for us to see what you think about our presentation. And also, if you have any ideas about next topics for our next events, please submit. We're always grateful for that. Thank you, guys. Maybe you have something to say, Philip?
No, I don't have anything to say. Just waiting for feedbacks.
Yeah, cool. So I wish you a great evening and see you at our next event. Bye-bye.
Thank you very much. See you.